The purpose of this problem is to find the sine series of ax plus b with interval 0 to L for these generic values a, b, and L, so that if you have a specific homework problem with some values of a and b and L, you can watch the formula at the end of this video to check whether you did the homework correctly or not. Of course, you should do the homework honestly, doing all the integrations as necessary, and also you should watch this video to check if you got it wrong, where you got the wrong signs or whatever. Okay. All right. So here's the formula for sine series. Bn is given by this integration, and the answer has to be written in this series, which is called the Fourier sine series. So let's do the calculation. Because this is a polynomial times a trig function, we have to use integration by parts. But we're going to use a modified version of the integration by parts, which is quicker. It's called the tabular integration. You can just watch me do it, or if you do not believe what I'm doing, you can also do the traditional integration by parts to see whether I got it right or wrong. Okay. Tabular integration goes like this. You put the derivative part, ax plus b, on the derivative column, and then the integration on here. And then you start differentiating the derivative column. Ax plus b differentiates to a, and then a, that's a constant, so you get 0 when you differentiate. Then you work on the integration. Sine integrates to negative cosine, and every time you integrate sine something x, this coefficient of x, you take the reciprocal of it and you have to put it in front of it. Okay, so if you integrate one more time, another reciprocal comes out, and because cosine just integrates to sine, it's still negative. And you've completed these two columns. Now for the sine column, you just start with plus and you alternate, so plus minus plus. So you're done with it, and once you're done with this table, then you have to know how to multiply it to get the results. The result is obtained like this. You go this direction to multiply, so you go across and slightly tilt downwards. And so you multiply positive 1 times ax plus b times this, so it's still a negative, right? And then negative times negative is positive, so a times this should be the answer. Okay, so you can read off the result of the integration and put it in like this. As you can see, I put the negative of ax plus b, and then L over n pi cosine n pi over L x is here, and a times L squared over n squared pi squared is here. Negative times negative is plus. Okay. Now we are going to now plug in L and 0 because it's a definite integral. So plugging in L does this. L and L cancel, so you just get cosine n pi, right? L and L also cancel, so you get sine n pi. When you plug in 0, this will be 0, and this will also be 0. But be careful, cosine 0 is not 0, so this is going to be important. Okay, this is a non-zero value. However, sine is 0 is 0, so that's going to go away. And then to handle cosine n pi and sine n pi, you really need to memorize the fact that cosine n pi is negative 1 to the nth power and sine n pi is 0. Okay, so using this, you can replace the cosine n pi as negative 1 to the nth power. Sine n pi is 0, so that just goes away. That also goes away. Sine 0 is 0. And this is cosine 0 is 1, so this is left. Okay. Yeah, and by the way, this sign here, this should be plus because there's a minus before, but 0 when you plug in and you have to subtract minus is plus. Okay. So hopefully you can follow this calculation. Make sure you see that the signs are correct. And then now I see that L over n pi is a common factor. Let's bring it outside. So I factor that outside. And because L and L cancels, this can be simplified as 2 over n pi. And for this one, I can't simplify anymore, so I'm going to leave it like this. So here's the BNs. So that's the answer for BNs, but that's not the answer for the question. You really need to plug them into this formula I discussed in the beginning. So this BN has to be replaced by what we obtained, and therefore the final answer is this. Okay. So if you have the homework for some specific values of a, b, and L, just replace those a, b, and L in here and see if your calculation matches with this formula with those values of a and l and b.